We got the Zwitter ion here. So can I give the statement? In order to get the Zwitter ionic form, both pK1 is also involved and pK2 is also involved. Correct na? So how can I calculate according to the formula? pK1 plus pK2 by 2. The exam undoubtedly they will give. If they did not give, you have to remember the amino acid glycine pK1 and pK2 values. pK1 value is 2.34, pK2 value is 9.60 by 2. So the pI of this amino acid is 5.97. So you have to consider where the amino acid is exhibiting in which form? Zwitter ion or neutral form. To get this neutral form, which groups are involved? You have to take the average of those two groups. You are getting? So now this is for simple glycine and there is no ionizable group also. Now you people only answer this. First, I don't want any correct answers. I want you to explain me correctly. What is the amino acid I am taking? Glutamate. What extra group it is having? Is it ionizable or not? Ionizable. So how many functional groups? 3 functional groups. Very, we can't say functional group, 2 functional group, 1 R group. R group is also ionizable. How many forms I get? 4. Original form? Plus 1. Leave about it. Carboxyl group. There are 2 carboxyl group. Now you people answer. So R group is also carboxyl. Functional group is also. Now tell me which lose the proton first? Why? How can we say? Everything depends on the pKa value. Correct na? How can we judge only this will lose the proton? Correct na? Suppose this carboxyl group pKa value is 4. The R group carboxyl pKa value is only 3. Then who will lose the proton first? R group. So who will lose the proton again depends on the pKa value. Okay. So now let's look into this. So here they have written pK1 value is 2.19, pKr is 4.25, pK2 is 9.67. Here you can tell here we can easily tell who is going to lose the proton first. pK1 followed by pK2 followed by pKr followed by pK2. We can easily conclude. First what we have to calculate where it is exhibiting in Zwitter ionic form. Now first what group it is? COOH, which is functional group, NH3 plus. Correct na? Then extra COOH group. What is the net charge? Plus 1, 0, 0. Correct na? Net charge is plus 1. Now who is going to lose the proton first? Carboxyl group, which means pK1 or pKr? pK1. So which this carboxyl group is losing the proton? So COO minus. Can I say minus 1? Plus 1, and here what is the 0? 0. So plus 1 minus 1 cancel, net charge is 0. Correct na? Next, which group is losing the proton? pKr. Now what is the charge? Just tell me. Minus 1, plus 1, minus 1. Minus 1 plus 1 got cancelled, then I got minus 1. Then who will lose the proton? NH3 is going to lose the proton. Hence tell me. Minus 1, 0. Very good. When NH3 plus lose the proton, it become NH2, which is 0 charge. Then minus 1. What is the total charge? Now where is the Zwitter ion? Here. Now all of you answer why I cannot take the value of pK2. See, because it is very easy. In the formation of Zwitter ion, pK1 is definitely involved, followed by pKr. So you have to take either side. Okay, that is a common hint, but you should not follow in that way. You have to consider which groups are involved in the formation of this Zwitter ion. Correct now friends? Tell me why it is only involved? Because this carboxyl group is lost. Which is what carboxyl group it is? pK1. Correct now? And this is what friends? pKr. And this is pK2. Correct na? You only tell me pK2 is involved. What is involved? pK2 is not involved na? What is involved? pK1, pKr. Correct na? Hence, how can I calculate this? pK1 plus pKr by 2. So how much it is? 2.19 plus 4.25 by 2. So the PI value is how much? 3.22. for the amino acid glutamate. Okay, now you all people calculate and tell me this. This is for histidine. Histidine having what group? Imidazole, which is definitely what kind it is? Ionizable. Correct na? So there are how many forms are possible? 4 forms are possible. Correct na? Now you have to calculate spontaneously in the exams. Okay, exams all this much details won't give, no. Okay, you have to remember everything. So what they will give in the exam? PK1, PK2, PKR. If they did not give, you have to remember them. So PK1 value is how much? 1.82. Okay, then PK2 given 9.17, PKR given 6. You remember what is the specialty of histidine? It is the only amino acid whose pK is near to the neutral pH. Correct na? Act like a both acid also, act like a base also. Now all of you please answer. If you look into this PK1, okay, tell me the original form now. Okay, this is the original form. What is the charge here? COOH 0, NH3 plus 1, and this is what? Imidazole having extra what group? Amino group. This is what amino acid? Positively charged. Lysine, arginine, histidine. Both 3 are positively charged. Obviously having what extra group? Amino group. Can you see that? Plus 1. So net charge is plus 2, which is original form. In the original form, net charge is always here plus 2. So they don't ask anything. Okay, they'll just ask you the net charge. Okay, at a specific pH. Okay, that I will show you in the upcoming slides. Now, who is going to tend to lose the proton first? Carboxyl group. So what is the charge or what is the pKa? 1.82. So it is obviously going to lose the proton. How much here? -1 here, +1 here, +1. Very good. Which is +1. Can I say this is not the neutral form? Yes. Correct now? We haven't reached the neutral point. Now who is going to lose the proton now? Which group? How amino group, friends? PKR. Correct now? R value is how much? 6 only. So what is the charge here? -1 here, +1, and what about here? Here PKR is losing. Very good. Here it is the 0. So I will cancel the +1 -1. Net charge also 0.
I guess it's audible now. It's audible now. Hello, hello, hello. Is it audible now? Yeah, fine. Thank you. Thank you so much. Some glitch has been happened. Okay. So let me once again explain that what we have seen here. Yeah, yes, now it's okay. Fine. So gravitational field, okay. The gravitational field is nothing but at a point in a space is the region around a mass where another mass experiences a gravitational force. Okay, gravitational force. So one more thing, like we have seen that like voice has been glitched. No, once again I will explain that. So gravitational potential and gravitational field. So potential in the sense how much like capable of that object, and the field in the sense like the around that surrounding, how much a person can, like if I want to beat some person, okay, if I want to beat some person, my hand will go up to this point. After that point it won't go. So my field is up to this point only. After that point there is no field for me, right? So the same thing in the gravitational potential and gravitational field also. So we will see what is gravitational field. It's nothing but at a point in a space is the region around a mass where another mass experiences a gravitational force. Okay, so there is a field, and if I take a mass to that field, it experiences a force. So gravitational field intensity is denoted by the letter G, capital G. Like for gravitational constant also it is G, right? But it is it is nothing but force by mass. So what it is force by mass in the sense we know that force is nothing but force equals to capital G capital M small m by r square is the gravitational force, right. So what is the thing given? Let me take this is for in Gi, okay, intensity. So Gi is equals to G capital M small m by r square by m, where mm will get cancelled. The final formula will be, yeah, this is the final formula, Gm by r square, where G is the gravitational constant, 6.67 into 10 power minus 11. So the SI unit is Newton meter square per kg square. If I want to find this SI unit, I can use the formula and I can get the SI unit. Yes. So what about the potential? So potential is nothing but gravitational potential at a point is defined as the work done per unit mass in bringing a small test mass from the infinite to the point. So I am bringing some test mass to test whether the object having the field up to which point, right. So the formula, like it is denoted by the letter V, so W by M, okay, like potential, like work done per unit mass. So for a point mass, it is V is equals to minus Gm by R is the, yes, minus Gm by R is the formula for the point mass for the potential, gravitational potential. So remember the formula, V is equals to minus Gm by R. For the previous case, the intensity is force per unit mass, okay, force per unit mass. You can take the formula, you can note down that. So next one is the relation between field and potential. So the relation between field and potential is G is equals to minus dV by dr, like gravitational field is the negative gradient of the potential, like negative gradient, it's no negative gradient, in the sense like the differentiation will take dou V by dou R will say no, yes or no. So dV by dr. Yes, it's same like electrostatic. See the current electricity, like the first chapter, electric current and charge, yeah. So it is the relation between the, like whatever we see in gravitation, the same concept we are going to apply in that class 12th. Yeah, obviously electrostatic. When we bring a charge close to each other, formula is equals to F is equals to K Q1 Q2 by R square, right. The same formula we have seen now, force is equals to G M by R square, right. So gravitational field due to uniform sphere. So outside sphere it is, let me take a pen, yeah. So outside the sphere in the sense, so if I consider this is the sphere, this is the sphere, okay. So outside the sphere they are saying, so R is less than capital R, I mean R, small r is greater than capital R, okay. On the surface R will be equals to R inside the sphere, So outside the sphere in the sense, like I have taken the R is the outside the sphere, radius of the sphere is capital R, okay. Radius of the sphere is capital R. So what will happen? Obviously R will be greater than R. On the surface in the sense, both capital R and small r will be equal. Inside in the sense, R is here, so R will be less than capital R, okay. So now the formulas are, for intensity, G is equals to Gm by R square. For this, see one more thing, this is R square for small r, like this small r we have taken, but on the surface capital R, but inside the sphere capital R cube, R by R cube, Gm by R square is the first one, Gm by R square is the second one, Gmr by R cube is the third one, okay. These are the three formula when we are using R greater than small r greater than capital R, R is equals to R, and capital R greater than small r, okay. Yes. So what about the potential? So potential is minus Gm by R, okay. Here small r, here capital R. But when it comes to the inside the sphere, no, minus Gm by 2R cube into 3R square minus R square, okay. So this is the one of the formula you need to remember, like it's a little bit big, no, minus gm by 2r cube into 3r square minus r square, 3r square minus r square. Okay. So once we complete the formula, we can go for the next. You have taken the formula, right? Yeah, we'll go for the next one. So graphical representation, graphical representation. So when G versus R, like that is the gravitational intensity versus R, okay, hyperbolic decay outside, linear inside, okay. So whenever they are asking about the gravitation, the graph questions related to the intensity and the radius and potential in the radius. So hyperbolic decay outside, linear inside. So inversely proportional outside and parabolic inside. You can take a note of this, this is important. So they may ask a question related to this graphical representation with V versus R and G versus R, intensity versus radius and potential versus radius. So once again we will see the key concept and results. So gravitational field formula and its type, which type they are given, vector, scalar they have given, and the unit also they have mentioned. Okay. So gravitational field gm by r square, gravitational potential minus gm by r, potential energy g m1 m2 by r, that is in terms of minus for potential and potential energy, and the field from potential, it is g is equals to minus dv by dr. It's like the gradient will take. Okay. So for this no field, there is no type. Okay, there is no type, it's a scalar or vector, it's not there, and unit also it's not there. You can take a note of this. So mainly we need to focus on the concept, a graph and the unit, that's what we have seen, and derivation, composite system and the potential field relations. The main thing you need to take a note in this concept, right? I need to know the gravitational field formula, potential formula, and then the relation between the potential and the field, and what is the formula, whether like radius is less than the radius of the sphere or greater than the sphere or inside the sphere, like on the surface of the sphere. Okay. So these are the things you need to take a note. So when we go into the questions, no, the first question is given, yeah, for a satellite moving in an orbit around the earth, the ratio of kinetic energy to the potential energy. Okay, kinetic energy to the potential energy. Can you give answer for this question? What is the answer for this question? Yeah, little bit I'll zoom it out. Now it's visible, right? Yeah, for a satellite moving in an orbit around the earth, the ratio of kinetic energy to the potential energy is, what is the formula for kinetic energy, guys? What is the formula for kinetic energy? Formula for kinetic energy, yes, it is K is equals to Gmm by 2R. Okay, 2R. What is the formula for potential energy? Potential energy, and this is kinetic energy, right? So minus Gmm by R. What they are asking, kinetic energy to the potential energy, right? So kinetic energy divided by the potential energy, which is equals to Gmm by 2R divided by minus Gmm by R. So where I can cancel it out, Gmm by R, no, I'll get the final answer as minus 1 by 2. I need only the magnitude part, not the direction. I need only the magnitude. So what will be the answer? The answer is 2, option 2, 1 by 2. Yeah, it's correct. Option B is the answer. So those who guys missed out this PYQs, no NEET PYQs. So same question we have here, that is, yeah, the escape velocity from Earth is VE, that is VE, and orbital velocity is V naught. Yeah, this is VE and this is V naught. What is the relation they have asked? So the same question we have solved in the NEET PYQ, okay, in the previous session. So velocity VE is equals to, is it visible? I will change the color. Okay, VE is equals to root over 2 GM by R. Okay, and what about V naught? It's nothing but root over GM by R. Okay, that's it. So when I take this two equation and if I want the relation between the VE and V naught, so either I can divide escape velocity by orbital velocity or orbital velocity by escape velocity. Yes, it's a previous lecture only. Like some of the guys have missed, no. So I have taken the same question. I want to explain it, no. Yeah. So option will be obviously B. Escape velocity is equals to root 2 times the orbital velocity. So now one more important question, like it's more interesting question, I guess. So let me zoom it. Okay. Yeah. At what height from the surface of the earth the gravitational potential and the value of G are minus 5.4 into 10 power 7 joules per kg, 6 meter per second square respectively. I need to find the height here. I need to find the height. What is the relation? What is the relation? I have here. Gravitational potential is the one of the relation here, like one of the equation, gravitational potential and G. Okay, from these two equations I need to find the height. What are the equations first of all? What are the equations? What are the equations? Yeah. So potential as well as the gravitation. I need to know the equations first, then I can easily solve that answer. Yeah, give. I'll wait. Wait, sir, solving. Okay, solve. I'll wait. I'll write the formula here, you can take a note of that. So V will be equals to minus Gm by R plus H. G will be equals to Gm by R plus H the whole square. These are the two equations for the potential as well as the gravitation. Okay. So from these two equations I need to find the height. Yeah. So what can I do? So V by G is nothing but V by G. Okay. Or else I can say that Gm by R plus H. Gm by R plus is there, no? This one I can write it as Gm by R plus H into 1 by R plus H. So what is Gm by R plus H? It is minus V will come, no, minus V. So G will be equals to minus V into, minus V by R plus H, minus V by R plus H. See, note down guys, this is gm by r plus hd whole square. So, 1 square I have taken separately. So, what about remaining gm by r plus h, which is equals to minus v. So, minus v by r plus h. So, what is the values are given here? So, v potential is given minus 5.4 into 10 power 7 and the gravitation is given as 6. So, I can use that, and radius of the earth is 6400 kilometer. So, 6 is equals to minus of minus 5.4 into 10 power 7 divide by 6400 plus h, that is it. So, from that I can find the value of h. So, answer is 1, your message, it is nearly equals to 2600 kilometer. Okay. Yeah, that is the answer. That is the answer, guys. So, hope you got the answer. No, I hope you got understood about the question. So, V is equals to minus gm by r plus h and g is nothing but gm by r plus hd whole square. Yeah, we will go for the next one. Okay. From this question we will stop. Okay. A particle is placed inside a thin spherical shell. What is the net gravitational force acting on Earth? Net gravitational force acting on a particle, like when we keep inside a spherical shell. You can give answer directly here, because like when we keep a particle inside a thin spherical shell, no, it is 0. Yes, 2016 and 2025 is tougher. Like if you study, no, it will be easy, guys, that's it. Yeah, answer is 0. Directly you can say, when we keep inside a thin spherical shell, inside will be 0. Gravitational force 0, 0, 0 is the answer. Yeah, because placing inside, so answer is 0. Yeah, intensity 0, no. Obviously. So, thank you guys. We'll stop up to here. We'll meet in the next session, that is tomorrow 10:50 sharply we'll solve the PYQs, and 11:50 we'll start with the 100 days challenge. Okay. So, stay tuned up to that. Bye guys. Bye bye.